Hi there guys, I'm Chris Bowden and welcome to the Geek Group. We are here today on the Equipment Autopsy set where we are playing with what is absolutely in no way a phaser or wannabe phaser look-alike thing, because that doesn't look in any way like a phaser. Not even a little bit. This is actually a hair styling dryer. I don't know why they felt the need to illuminate that so thoroughly for everybody, but there it is in big purple 80s decor on top. Hair styling dryer by Pencrest. And on the bottom, we can see it was actually came from a JCPenney catalog. At some point, we don't know the era, well, the year this was made, but if you look at it, that's screaming 80s. This was probably the same hair dryer that, I don't know, Sheena Easton used. Yeah. So hair dryers are pretty cool, though, because they're all pretty much the same. It's power supply to a fan to a nichrome wire heating element, air comes out. Beyond that, inside, they're all pretty much the same. Outside, they get radically different. Like this one looks really dorky. So let's take it apart and see how it works, because you can do a lot of fun things with a hair dryer. This is one of those things where you can use junk stuff, because, wow, you can find hair dryers everywhere in the junk for nothing. It's got a metal tip. And if you need resistive ballast or a dump load for a capacitor bank or stuff like that, these are really handy for that because all it is a big resistor. Now, we took the front off. If there was only one screw that held this whole thing together, I'm going to freak out. Yeah, it just clips in there. All right, so now we're down inside. You can see that's the fan. Oh, wow. Okay, this is... Oh, there is no way. I am going to laugh like hell if I just found what I think I did. This could be so funny. I think somebody's been decorating back here, and York needs to move. That needs to move, because I don't know if you guys are aware of this, but you can't open the drawers if the top is closed. We're going to need that. All right, guys, I think we just found something really awesome. This is funny. The inside of this is not 80s vintage. I could be wrong, but I don't think I am. And we'll ask the viewers to tell us for sure. Just in case, I'll take all the precautions. But let's pop this guard off, and I will share my findings with you. All right, now, here's inside a hairdryer. Now, this is a real autopsy, so we have to talk about how it works. And you'll notice, usually in the autopsies, the first thing I do is cut the cord off. I broke that habit, and I didn't cut the cord off, and I'm going to ask somebody nicely, do we have a place we can plug this in? It should probably not plug into wherever we have all the lights, because it's going to draw a couple hundred watts. But I want to show this actually working. It could be kind of cool. All right. Power cord. Ah! Settle down now. Okay. Now, and we'll just set the power cord up here, just in case of emergency. Now, we'll look in here. Now, it's a hairdryer, so its entire mission in life is to make hot air. And astute viewers right now have noticed the little thing I saw earlier. See if you can figure out what it was that I noticed that made me giggle. All right, now here is how this works. This is a squirrel cage blower. You can see the impeller right here. Okay, so this blows air. And it sucks air up in the bottom. That's our air inlet down here in the bottom. And it blows it out around here. And since there's only one hole, it goes out through here. These are nichrome wire heating elements. So if I turn this on, let's see, does it go hot first, then cold? Yes, okay. If I turn this on, you'll see the wheel turn. And then the wires will heat up. Now, you can't touch the wires because they're actually high voltage. Where you touch the wire depends on the voltage. This here is the little thermostat or protective heating element, but it's already making hot. And if we turn the motor off, these will get really, really hot and start to smoke. See, they need the constant cooling. And you can see them glow red there. And the burning hair is lovely. And thankfully, it has a little fan to fill the whole room with the smell of burning hair. All right, so that's how a hairdryer works. They're really that simple. Now, this is the thing that I noticed earlier And I'm really curious to see, but I think, I could be wrong. Let's get a really close look here. See that? This white stuff that the heating elements are mounted on? Now, the style of the hairdryer is very, very 80s, maybe 70s, okay? That white stuff right there with the little fibers, and it's chalky. When I first looked in it from the end, I just figured it was fiberglass or maybe a high-temp plastic. But if you look at it, it's not a high-temp plastic for sure, and I don't think it's fiberglass. I could be wrong, and I'm sure some of our more astute viewers will catch this, but I think that's actually asbestos. Which is pretty cool stuff, but don't play with it at home. The big thing to know with asbestos is as long as you don't eat it or breathe it, it's pretty much not going to hurt you. I mean, it's pretty harmless stuff. Asbestos is dangerous when you disturb it and it becomes fibrous. When it becomes, when you break up, when you create asbestos dust, basically, and you let all of its little fibers out into the air, then it can mess you up. How do I open that? Asbestos just, up there on the pipe, not going to hurt you. It's fine as long as you don't make it angry. I think that's metal. All right. There's a little screw way down in there. That's going to take doing to get to. See, I'm thinking they put it together that way I can take it apart, but there are no screw holes in the thing. I wonder if I just... Nope. I was hoping the bottom snapped in, and I'm pretty sure it does. I just don't know how to unsnap it. So we're unplugged, so we're safe there. Let's see if we can find a long, skinny screwdriver that can reach up in there and get that impeller off. Now we'll pop the impeller off. Now we can see right down in there, there's a non-trivial amount of hair. But now that we got the impeller off, we can see the other 3 screws. So we can take those off. And there really shouldn't be much more to this than a switch, a fan, a heating element, and a safety device. Little thermostat thing. Okay, that should... 2 little motor mount screws way down in there. Oh, and they're on tight. Come out. It's kind of gross with all the hair in here. In case anybody's wondering, we got this at Goodwill, I think, judging by the sticker it had on it. Okay, and there's the whole thing. It pulls right out just like that. Yeah, the color wheel says 70s. The wheel shines through a little hole in the side. And when you pull the pistol grip, it tells you what setting it is, depending on what's shining through the hole. So all you're seeing is a little tiny bit like that. And if it's off, it's silver. If it's on, it's red. And if the motor's on but the heat isn't, just blowing cold air, it's blue. So that's off. And there's the really jank motor, but you can't give the motor too much grief because it still works, and that thing's probably 30, 40 years old. I mean, that motor's got some time on it. Now, down here, this is kind of impressive. Look at this. This is a cheap little disposable commodity, but on the side of the motor, see that? Well, that is where the brushes go. And we can, if we use a proper screwdriver, we can reach in there. Let's find a good straight blade screwdriver. Here we go. Okay. Now watch. We can reach in on that side piece there. Turn that. It's a big screw. And take that screw off and down in here, get our pick. See, we just pop that piece up, and as that comes out, there's the holder, and this right here, this exact piece, that's the brush. Motors have what's called brushes, and the brush is the part, you can see the end of it. See how the end of it's round, and it's kind of caved in a little bit right here. It's concave, and it's on a copper spring, and the copper spring pushes it in, and this sits like this on the side of the armature of the motor. The armature is the part that spins around, and you can see this down in there because motors work by spinning an electromagnet. And you can see right here, see that black spot? And it's hard to see through. If I had a white background, here, this will work. All right, here, I'll put this on a light-colored background so you can see through there better. But as you look through, you can see up here, that's the one we opened up. So you can see there's a hole there where the commutator goes through. So if I grab this commutator, and I line it up, and I put that in there, watch down inside the hole. Watch right here. Okay, see how there's an air gap? You can see through that spot. If I push down on the commutator, boop, see it poke through? Now what this does is the wire connects up here, and you saw the wire I took off right there is the wire. So that's the motor power feed. This carries the power through down to the motor, and the motor has this part here. This is the armature, okay, this part that turns in here. The whole rotating assembly is the armature. Now on the armature you have the commutators right here, and each one of these on the end has a little solder joint, a little wire that goes up here, and you can see these coils of wire. And it's the coils of wire that create the magnetic field that makes the motor turn, because the way the motor works is you're carrying electricity in here. It goes from the commutator down the armature out to the windings, and these are the windings, and the windings generate a magnetic field, and that magnetic field is out of alignment with the field winding, and that's this big thing here. This big winding out here is the field winding. This is another electromagnet, and at any given moment, the electromagnetic energy here doesn't line up the way it wants to with the electromagnetic energy in there, so it makes it want to turn. Now, here's where things get cool. If you just had a constant connection here, the motor would only turn half a turn and then stop. So what they do is there's a whole bunch of little windings, and they're all staggered out. And if you look in here, let's take the big mess off the end so we can get a better look at the windings, because that's way more interesting than just the mess up there. Let's see if we can get this apart easily. Okay, there. Now we'll get rid of your sister's hair, because she never liked me much anyway. All right. Now that hair's still bugging me. Let's get rid of all that hair on there. Let's clean this up a bit. There we go. All right, let's get that hair right out of there. Oh, yeah. That smells lovely. Just scratch off the rest of that. And now it's melted hair. Tasty. Oh, yeah, that's lovely. There you go. Share that with the video crew. There we go. Okay. All right. That's way more better. Okay. It gets hot pretty fast. Now, we've got a motor. Now, this is much more interesting than just a hairdryer, because we get to talk about motors and how they work. So now that we can actually see everything, let's take this apart and really dig into it and talk about its component pieces, because right now the whole thing's only held together with one bolt. And this is cool because this is actually a pretty well-built motor, especially by today's standards. By today's standards, they're just little crappy stamped things, and it's all garbage. They just use permanent magnets, and it sucks. So, all right, let's look at the basic components here. We've got our output bearing here, and that holds our armature. Our armature goes through down here to the back bearing. We've got our brush holders, our commutator, field windings out here, armature windings down there, and a bit of string, which I have never seen before, but I noticed that earlier, and I think it's kind of cool. So let's find out about this. Now, we'll slip this right apart, and let's look at the individual pieces. A bearing, nobody cares. It's a bearing. You've seen them before. All right. It's still really warm. Okay. Now, this is our field windings, and it's 2 electromagnets. Okay. It's just a coil, and it goes out, and these energize this. And you can see it's made up of stacks of laminations, and they're separate, and they hook together with a little notch. They're actually exactly the same, and they just make them on machines, 1 million a day. And you just take 2 and put them like that, and there's a tongue and a groove and a tongue and a groove, and boop, they just fit right together like that. Okay? So you can see the laminations. And the reason why they do this with laminations is it's lots of little tiny pieces of steel, and it works better when you're making a big electromagnet. It works a lot better than using just a solid piece of steel. This saves a lot of money on metal, and it's a lot easier to make, especially for complex shapes. Because if you had to make that out of a single piece of steel, you'd have to carve that out of a solid block or start with a casting and machine it down. And by doing it out of laminations, they just start with a sheet of that metal, and they stamp them all right out. So they can get any complex shape they want, like this, out of little thin metal and stack them up, and then they just put a rivet. You can see the rivet right here. That's a rivet, and so is that. And just stamp them on there. And then they put the coil bobbin on and wind the coil. So that's how they make the electromagnets. And let's cut that off. You can get that out of the picture. And you can see on the main power wires there that the electromagnets are powered off the same voltage and at the same time as the commutators. And we talked about the brushes earlier. And you can see when I took it out, this one popped out. It's the spring pushes it forward. It's a very gentle, very soft spring, but it's enough to do the job. And these allow you to make an electrical connection to something that's moving. So, and you'll see brushes a lot in different types of motors and stuff like that, but you'll also see them in like the air raid siren. Our big air raid siren spins around. It's got a big giant set of brushes down inside it, and we'll show, if you watch the air raid siren video, you can see that. Now here is where the action happens. This is where everything's moving. This is the armature, okay? Now, we've got the commutators back here. These are the contact panels, and these are just copper slats, and they're all separated. You can see the little black thing. And the copper slat connects out to a winding. And now here's the view I wanted to show you before that we couldn't see. Look at the end. And you can see that's a winding right there. And then just under it, at a slight angle, there's another winding right here. And the winding goes down through the inside and around the bottom and then back. So that winding is only off at that side. And this winding has a pair, or has a paired matched winding right over here. See how this winding is parallel to this one? Well, if I turn the whole thing a little bit, now this winding is vertical and it pairs to this one. And every time we do that, it changes around. Like that. So we have winding. Okay, now this is our top one, so it's easy to keep track of. And we know it's got a pair over here. So there's 1 pair, 2 pairs, 3 pairs, 4 pairs, and then we turn it one more time. Now this one's vertical on the other side. So we see we have 4 pairs. That means that this motor has 4 poles. And you can also count that by counting the slats down the side. We have 1, 2, 3, 4 on this side, and 1, 2, 3, 4 on that side. And we know it takes 2 holes for the winding to go through. So that tells us that this is a 4-pole motor. And that means it has 4 points like that. Now this is a 4-pole motor. This isn't a 4-phase motor. Okay? Because first off, I've never seen a 4-phase motor. Almost all motors come in single-phase or 3-phase. 3-phase is for big industrial use, and that's a whole different thing that we get to talk about someday. But this is a 4-pole motor. Now the poles are the steps that it's going to get as it goes around. You could make this motor work with just a single pair of windings, and it'd work just fine. But it'd have a big bump to it. You'd feel it go, like if you squeezed it while it was turning, you'd feel it go foom, 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 foom. Well, the reason they have so many poles is it's every time one of those comes into alignment, it's going to give it a little kick. So that controls how smooth the power is applied, and that the more poles you have, the smoother the motor operates and the lower the vibration, and the lower the speed you can make the motor work. So you can get 4, 5, 6, 7, 8 pole motors. The most I've ever seen is 8, but I'm sure somebody out there probably makes a 12. But that's where it all comes together. You'll learn a lot about this if you get into models that use electric motors, especially things like model trains, where it's really important to be able to make it go slow. And the more poles you have on your motor, the slower your model train can go. So yeah, that's armatures and the basics of small electric motors. That will not spin on its own. I want to take this one apart because I've never seen one with string on it before. That's kind of weird. So let's dig into this a little bit while we're here. Because we're here. Hey, you're not in a hurry. If you got something to do, pause it. Go do what you got to do. But I got time. Let's check this out. That's the point, is to explore this stuff and learn about it. Let's pull that right off. This is neat. This is so cool. String on an armature. It means some guy made that. Some guy wound that on there by hand. It wasn't just a machine that did the 10,000th one that day. And there's another layer of string under it. Now, this is kind of hard to see, but I can see on my monitor here that the camera's actually picking it up, so I'll talk about it. Look here. You can see those little tiny wires. That wire goes up there into that winding. It comes down, and it goes to this contact plate on the armature. And you can see a separate little winding on each one of those. So it's really cool. All right, so that's your look at motors, armatures, and the basics of inside a hairdryer, complete with bonus asbestos. Now, keep an eye out for asbestos. If you're taking apart old things, you'll probably come across it here and there. Now, this, like this, really isn't that dangerous. I mean, as you wash your hands before you eat anything, okay, that's important. And don't smash this up into little tiny pieces. Don't sand it or file it or grind it or anything that makes dust. Don't do that. But to just hold a piece like that, it's not going to kill you. Don't get into all the hype over all the be terrified of everything in the world. There's real good and evil in the world. Don't make up your own danger. So yeah, when you're done with this, put it in a baggie and throw it away. Okay. Don't grind it up and put it in your sister's inhaler. That would be bad. So I'm Chris Bowden. This is an Equipment Autopsy. I want to thank you guys for watching. You have fun. Please remember to like, comment, subscribe, rate, or whatever it is they let you do at this point, because YouTube changes every 10 minutes. And as always, we'll see you next time.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.